Zach, hello. Scorpra, hello. Congrats on the first. Um. Okay. I would love to just avoid doing this problem, so I'm just gonna avoid it for now. um. Happy Saturday to you too, Zach. Hope your stream was good. Oh, I was struggling with this one, the one I ended on Thursday. I am, yeah. um, my series just was not coming out quite right. Oh, you know what? I don't know if he told you, but this reminds me. Meriwether said he's trying to catch up to this class in time for Fourier series. So that's exciting. Let me put these. I was putting these into Desmos, and they weren't quite. Oh, because doing the choose in Desmos was the issue, I think. Fourier series coming, awesome. Do you note the integral of smiley face as a frowny face? That would reflect how I feel about it, Cytos. Um, Maybe okay. So when I was looking at Desmos, they looked completely wrong. That could be because of the choose issue, though. Can Desmos do gamma? Would gamma function even be what I want? Wait, no. I think I said that the Desmos choose should work. Hey, SG1. No, I'll just put the actual series that I got in. Let's start with that. Hey, Critical. And let me make sure that I'm not being too stupid. N equals 0. Let's make it a constant. Deal with that later. NCR, New California Republic. Okay, so it's minus a half choose N. It does work? Okay. Ugh. 2n plus 1. X to the 2k plus 1. Oh my god, Desmos. I hate that you go down when I do that. Okay. 2n plus 1. Wait. No, okay, no, that... I do remember that happening. So this one, it might work maybe just around x equals 0. It's a very funky function. What was my other series? I thought... You're watching, that's why. Zach, I would believe it. It's like in my like computer science classes, like I call the professor over because I'm having an issue with my code, and then as soon as like he comes over and looks, it works perfectly. I had that happen like at least once, but I think multiple times. um. Okay, so I remember maybe why this I was having the same issue with this one not graphing. Minus 1 to the n? I would believe you. Arguing cats. Oh my god. Uh Yeah, critical. Let me. Oh wait. Oh, now it's graphing. You just need some computation time, maybe. Where? Oh, well, what? It's transparent now. I'm not sure why that one isn't graphing. Um, yeah, critical. Once I figure out this Desmos thing, I'm gonna. The minus one at the end fixes it. Interesting. Okay, I'll have to go back in my math and figure out where that's happening then, or figure out like why I missed that. Okay. I still don't look at what the other series gives also, but thank you for finding that, Zach. Do. Wait, you posted two things critical. Which one do you want help with? Both of them? Um. All right. You haven't asked a question well, so I'll do both of these, but I'm not going to do a bunch of questions in a row. I'll do these two though. What do you mean by writing it in calculus form? Freaking Logitech driver. One second. Lamp array translation service. Get the hell out of here. I mean, I never got to an answer, Fembucks. I mean, 5y. Are are you asking about like this one? Like you could write this equivalently as like, I mean, doing four primes is a little bit awkward. You normally once you get to four primes, you would do parentheses four like that. Well, and we don't need the of x. But these are like equivalent. It doesn't really matter which one you use. I still don't feel like I'm interpreting you right though. Hey Rex. What is the zero? Can both the questions are equal to zero? Uh, because there's no reason it can't be. When a differential equation is equal to zero, it's called homogeneous. I mean, you say this? Can be written I know, Zach. That's the exact thing that I'm trying to phrase in an easy way. Hey, Eldridge, yeah. uh, let me do non-homogeneous and say that homogeneous is the opposite. No, even then that's weird. Eating sweets in the back and forgot about me for like 3 hours. I mean, eating sweets is worth. You know what? Let me just say examples. I'm not going to say the general definition. It's just easier to see with examples. If you can get all your y, everything involving y is onto one side, everything involving x is on the other. So like y double prime plus y prime equals 0, that's homogeneous because all your y's are on the left side. On the right side, you only have a 0 that's left over. A non-homogeneous would be the exact same thing, but there's some function of x here that doesn't involve y. So we can just say x. Y double prime is the second derivative of y. Y is some function of x. It could be sine of x or e to the x or log of x or something like that. It could be anything, or like it could be any function of x. We don't know what it is. The goal of differential equations is to figure out what y must be. Um, and so um well, sure, e to the x on its own can't be 0. Okay, let's take a simpler example of a differential equation. Let's say y prime minus y equals 0, or if you prefer the other notation, we can say dy by dx minus y equals 0. I'm just going to tell you the solution to this differential equation is e to the x. And it's okay that this equation equals 0 because we're not saying e equals 0. We're saying this weird thing equals 0. If you figure out what dy by dx is, in this case, e to the x, derivative of that is still just e to the x, you can plug it back into the original equation and verify that it works. So there's a dy by dx there. I'm going to plug in e to the x for it. There's a y there. I'm going to plug in e to the x for it. So e to the x minus e to the x equals 0. This is a true statement. That's what this is saying. So Heidos is right. You technically need a constant here. I'm not worried about that. right now, though. Sorry, Indian Sky if I didn't say already. I see you, but I had a couple of differential equations up on the screen when I was saying that. I'm not sure which one you were talking about, but um, yeah, exactly. So if there's a function here, then it has to like so in this situation, the y isn't necessarily e. We're trying to figure out what it is. But whatever our solution is, we should be able to follow the exact same process of um, finding the fourth derivative, doing a plus, finding the first derivative, multiplying it with e to the x, and we should get 0. And the strategy for this one is a little bit um, there's a couple of different steps here, but we can go through them. The first thing I'm noticing is that we have a fourth derivative and a first derivative. We can do a little tricky thing. We can just do a change of variables here to make it'll be a little bit simpler, I think, if we take some other letter, whatever your favorite one is u. I'm going to make it equal to y prime. And the reason for this will become clear later on. For now, just go with it. If u equals y prime, then we can directly plug it into that y. The e to the x will get left alone. We need to figure out what y to the fourth is in terms of u. So I'm going to take this equation and take the derivative 3 times. And say that u triple prime is equal to the fourth derivative of y. Oh, shoot. Do you prefer the other notation? Because we can keep it in that other... Let me keep it in the other notation, because it sounds like you might prefer that. Go ahead. Or if you're okay with this, I'll keep doing this notation. Continue? Okay. If we do this change of variables, this equation becomes u triple prime plus e to the x u equals 0. And the reason I'm doing this is this looks like a separable differential equation. It's not even... No, wait. It's weird with a separable differential equation having a higher order derivative. It might be okay. It should be okay. This one, I need to plug it into Wolfram Alpha, but I think this is the strategy that we would use, because what we can do is subtract over this thing to the other side. Divide over the u. And now we only have u's on one side, and we only have x's on the other side. We can integrate each side. This doesn't feel right, does it? I'm doubting this method right now. What happens if when we do integrate each side? I might need to see this in the other notation, to be honest. We integrate each side with respect to x. Like, could we think... of it like this. That doesn't make sense. Does this trick not work with higher order derivatives? You know what? Even if this did work, we would get something that's not really integrable, would we? Um, well, so the equation involves derivatives, and if you want to get rid of those derivatives, you need to integrate because the fundamental theorem of calculus, or usually integration is usually involved in some way. Um, it might be in the background for a certain technique, but the y's are mixed up with derivatives in this equation, and if you want to get rid of the derivatives, integration is a way that you can do that. It might be easier with the Laplace transform, but that's definitely not something I can't imagine something that Criticals has gone over is supposed to use. Um, I'm gonna see what the answer is supposed to be because now I feel a little bit unsure of how I was trying to do it. I feel like it should be e to the x or something like that. Is my guess. That's not right. Let me give it the version after you sub. Take a prime off of each of these. Nope. Yeah, I never heard of that one. Hey, Krim, is there a more clever substitution we can do here? Like, what if u equals e to the xy prime? That's gonna be hard to solve for y to the fourth, though. Maybe. I don't know. That's gonna get very messy very quick. You think you got it? Like, you think you solved the problem? Just the basic concept? Oh, okay. say like I'm interested to hear what the answer is because this is a tricky one. Kiranjit, this is just a differential equation. I don't think it's part of a physics problem. How about a fourth order crim? The coefficients aren't even constant, so we can't even assume it's an exponential solution, at least exponential on its own. Hey, Cruz. Does separation of variables work when it's higher order? Equation, separation of variables, second order, for example. I'm doing good, Cruz. Thanks for saying hi. We got a tricky differential equation. Runge kutta? I think I've heard of this. I don't remember. How these work. Wait, this is the numerical? Oh, well, I don't think we're supposed to do that. Oh, I'm sorry, Karanjit. I'm not very good with physics. Like, what kind of physics? A non-constant coefficient means that there's a function as one of the coefficients, e to the x. If you have a differential equation, if you instead had like, like a 3 there, you can solve this in a pretty systematic way. It wouldn't be too hard. But because it's a function e to the x, it's tricky. Oscillation? Yeah, I probably can't do it, Crunchy. I'm sorry. My physics is pretty weak. How are you doing, Cruz, if I didn't ask you? Sorry. Roll from Alpha gets, that. Project Euler, I have before. I haven't for a while. But, I do sometimes, do some coding on stream. It's pretty sporadic. If the problem calls for it, or, like, against Zach, we have some occasional coding, like, competitions. Should we have a round 3? I would. Yeah. I used to make a point of doing them a lot more, but just been distracted with other things. Maybe an apple following us and start being super smart. You know, Cruz? I don't know. Expect to win by round 4, but getting better with each competition. Yeah, we gotta make it exciting for the people. Um, so critical. I don't know if you're just giving this a normal problem as your like ODE class, but this doesn't seem easily solvable. I don't think it has a clean solution, so I don't know why you'd be expected to solve it, but I like we could try Laplace transform if you've heard of those, but if you haven't, then like I don't think there's going to be a way. And even then, I don't know if Laplace transform would do it. Never heard of it? Okay, yeah. Do you want to talk about the first one you posted? Because that one does have constant coefficients. Calc 3? No, this is differential equations. Yeah, the top one I can definitely do. Krim is saying wait. Okay, so when you have constant coefficients like in this equation, um, well, there's a few things that are important here. Maybe Krim, I don't know. If you have a suggestion, feel free to let me know, but I couldn't find anything that's like that. Um, I would call this equation down here a linear homogeneous second order differential equation with constant coefficients. The differential equations be a little bit annoying with how many terms like this that it has, but they do all serve like a purpose. The constant coefficient parts we've talked about. Hey mathematician. And I'm saying this because it's good to know what the differential equation is classified as, so you know what techniques are allowed to solve it. Linear means that all of these y's are just kind of on their own. You don't have a y squared. Like, the y's aren't trapped in a function. If you have like a y double prime squared, this absolutely sounds like The Price is Right, Zach. Oh my god. The name of the song is "They Should Have Let Me Host Family Feud" by Englewood. What? It's just a random playlist. It's supposed to sound like a game show, though. That's a great call. Um, Transition. I can go back to it. I didn't end up having the energy to look at it again. Sosa Classica, thank you for the follow. Once I'm through with this problem, I can try that again. It's a complicated one. There are some solutions that people are posting in the Discord. I don't know if I wasn't like checking them for myself. McKendall, I have a bachelor's in applied math. That's my math background. Okay, but it's linear because like none of these y's are trapped inside a function is the point. You don't have like a sine of y, you don't have a y squared or anything like that. Hey Colton. It's homogeneous because all the y's are on one side and it's equal to 0 on the right. There's no like function of x over here like sine of x or something. I'm just using sine as an example, it can be anything. And it's second order because the highest derivative you have is the second derivative. And so when this is the case, including the constant coefficients, there's a really good guess for what the solution is, which is y equals e to some constant that I'm going to call r times x. And the point of this is that we can do kind of what we were doing before and take the derivative of this twice and plug it into the original differential equation. This is often taught in differential equations class without this kind of background bit, but I think it's good to know this because it's less memorization if you know how to just like do it for yourself. So if you take the derivative of our guess for the solution twice, that's what you get. So now let's plug all these back into the equation. So we get 5. Now y double prime is now r squared e to the rx. E is always the answer, basically. 750? Why is that? Minus 2 y prime is re to the rx. Bocce the Rock Season 2 confirmed. Oh, nice. Plus 5e to the rx equals 0. Yeah, just the y double prime is the second derivative. Yeah, it does feel like there's a change of variables somewhere in there, but I couldn't find it, Mega. Um, mathematician, I said I'll get to it after this. Jeez. Um, uh, no, Cytos, if you have a solution, please post it. And so the point of doing this is that we can factor out an e to the rx. 5r squared minus 2r plus 5 e to the rx equals 0. And this is a situation where we can say e to the x, or like this piece is never equal to 0. Like in the same way, when you have x plus 2 times x minus 1 equals 0, and you split it off into two separate problems, we can do the exact same thing up here. So we get one problem involving this, and one, oops, equals 0, and one problem involving this. Oh my god. Mathematician, I don't even know what to say that. But you find a way to annoy me every time you come here, so goodbye. Okay. um yeah, so the point here is that we don't get any solutions from this piece. Like e to the something is never 0. So we may as well just cross this out and focus only on the left side here. So, oh, okay, sounds good, Colton. Um, and then now on the left side, we have an equation that we can solve for r. And the great thing about knowing what r is that we already have our guess for what y is. We just need to know what r is. So this is the exact thing that we want. I think this is quadratic formula. So I'm going to say r is equal to 2 plus or minus root 4 minus... Oh, that's annoying. 4ac, it's 100. All over 10. The bit that I'm saying is annoying is that we're getting imaginary numbers. That makes the explanation a little bit more involved, but we can deal with it. So we're getting 2 plus or minus the square root of negative 96, which that shouldn't be a perfect square. We can probably simplify it though. What goes into 96? 3 In 32? Yeah. So we can rewrite 96 as 2 to the 5 times 3. That's the prime factorization. Oh, yeah. Okay. Territory found the best combination to use, which is 16 times 6. But this will get to the same result too, so. We can take a 2 to the 4th out of here, and I'm saying 2 to the 4th because that's a perfect square. We can square root that and get 2 squared. Everything else will stay underneath the parentheses. So 2 plus or minus 2 squared is 4, so that's outside. And then we have a 2 times 3 left over is 6. 10. And then we can cancel a 2, 1 plus 2. And then the square root of a, we can take the negative out and make an imaginary number I that we'll deal with later. That's okay. Over 5. Plus or minus. So in theory, we found our R that is a solution to the differential equation, but we have 2 possibilities of R because we have a plus and a minus, and our answer is imaginary, which, you know, we should probably not give an imaginary answer to a real problem if we can avoid it. So how we deal with that is we get basically 2 solutions from the plus and minus. So I'm going to say our first solution, y1, is e to the 1 plus 2i root 6 over 5. And that y2, our other solution, is e to the 1 minus 2i root 6 over 5. And I'm just trying to think of the cleanest way to do the next step here. I guess we'll do it individually. Thank you. Oh, yeah, sure, Zach. I'm debating if we should factor out the 1/5 first or not, basically. What we'll get for the entire solution is what's called a linear combination of these 2 solutions. So how we do that is we just add them together and stick a constant in front of each of them. So C1e to the 1 plus 2i root 6 over 5 plus C2e to the 1 minus 2i root 6 over 5. X, thank you. That was part of the format. And I guess I'm going to factor out the 1/5. I think it'll make it cleaner. I'm going to notice, or I'm going to know that I'm just going to take the first one for example. E to the 1 plus 2i root 6 over 5x is the same thing. Did I take the x out also? Wait, they both have x's. Okay. Yeah. It's the same thing as e to the 1/5 x times e to the 2i root 6 over 5x. Because when you have the same base multiplied, the exponents add. So I'm just kind of undoing that addition. And the reason I'm doing that is to get the real part separated from the imaginary part. So I'll make the next step a little bit cleaner. And so I noticed that both of these have an e to the 1/5 x. So I'm going to factor that out entirely even and put it all the way out here for now. There might be something slick you can do here too, but I think from here I'm just gonna use Euler's identity that e to the I theta is cosine theta plus I sine theta. And so we have an I in each of these these exponentials. And so the theta is the 2, the root 6, the 5, and the x. And for the other one, it'll be that same thing but with a negative. So plugging that in, it'll be C1 parentheses cosine 2 root 6 over 5x plus I sine, not e, 2 root 6 over 5x. And I am showing every painful step here. In differential equations class, they normally give you a formula at the end that you can memorize, and we are getting to that point. But if you don't like memorizing formulas, which I try to avoid if I can, this is the way that you do it without memorization. We're nearly there. We need a third parentheses. This, you just have to know, like, this is called Euler's identity here, and it's just a good thing to know, basically. Here's the problem you say with the quarter circle inside the square. Oh, okay, nice. Titus already has the correct answer. Oh, okay. Now in the next step, I'm going to distribute the constants into each of those. This is here's what's going to happen. I'm going to use the magic of copy and pasting. This is why we have technology. Oh my god, this is not why we have technology. Chaotic diamond. Yes. I'm getting to the end of this problem. Your problem is probably going to be shorter than the next one in queue, so I might get to you right after this one. I haven't had time to look at them, but... And hey, Central. C2. Okay, there. Test Tuesday. Ooh, geez. Okay, good luck. I can help you get ready for it. Okay, so all that's happened in this step is I multiplied in the C1s. So an unacceptable hey central time. How should I have time to better? I need to know. How did I get a negative 1/5? That shouldn't be there. Be faster? Oh, sorry. Yeah, my bad. Okay. You know what? I'm going to do another step. I'm going to say cosine is an even function, so cosine of minus x is equal to cosine of x because it's even. And also sine of minus x is equal to sine minus sine of x because it's odd. I'm going to apply it here to get rid of the minus sign. and I'm going to apply it here. Oops. Oh my God. There. To put a minus sign in front of the sign there. Okay. Almost there. I promise. So now we have cosines that are common terms. I'm going to factor them out. So we get c1 plus c2 times cosine 2 root 6 over 5x. And then with the sines, we have c1 minus c2 I sine 2 root 6 over 5x. And then these two things are just like, these are just two different real numbers. We don't care too much. Like the C1 and C2, they're kind of like meaningless. Hey, Phobos. So this is where we play fast and loose with our letters. Like this is a pretty common thing in differential equations where this is any real number, this is any real number. Let's just make up new constants. And rather than recycling through a bunch of different names, I'm going to reuse C1 and C2. So this entire thing, I'm going to call C1, but it's technically a different number, but we don't really care. Same thing here. I'm going to call that C2. And not only that, I'm going to go a step further and include that I inside of C2. That part, I'm not quite so clear on why that's okay, to be honest. But it's just any constant you want, basically. You could do C3 and C4, but I like to be incorrect, I guess. And this is the solution. So when you get imaginary roots from your what is called the characteristic polynomial, they usually give you a formula based off what your roots are. And so if you get roots that are, or if you find that r is equal to some number alpha plus I beta, so like, you know, here alpha is the 1/5, beta, I guess I should say plus or minus I beta. Beta then is the 2i root 6, or sorry, beta is the 2 root 6 over 5, because the I is part of the formula here. And so I say it's a confusing way, but if you get imaginary roots and you get it into this format here, the formula you can use, how did this negative come creeping back in? It's e to the alpha x times c1 cosine beta x plus c2 sine beta x. So if you just want a formula to memorize, that's what you would memorize. But if you don't like memorizing forms, you do the work that I did above. And that's a matter of preference. So I hope that helped. You prefer memorization? All right, fair enough. Then I'm gonna go on to the next question, but thank you for the question. Okay, it does look like Chaotic Diamond's question is quicker. So I'm gonna do that one first, and then Colded, I'll get right to you. Sorry to push you back in line. Chaotic Diamond, are you here actually? You stepped out for a second, it's okay. You are here? Okay, awesome. So we have a function defined for all positive integers, 1, 2, 3, 4, and satisfies the following conditions. Oh God. Mathematician, you are consistently rude to me. I'm no longer doing your problems. Please Stop making accounts. Okay. So yeah, this is, I guess you would call this a recursive function where the function is defined in terms of itself. And that's okay, but like, you know, we need to figure out what the heck this thing kind of means, or like, you know, how we deal with it. So they give us a definition for the function and a starting place. And that's all we really need to know in order to build up to f of 15. Kaboom. So if f of 1 is 9, let's try plugging in 2 for n here and seeing what happens. Sorry, so let me actually be more clear about what I'm doing. Take n equals 2, and now by the definition we're given up here, f of 2 is equal to 2 times f. Now n minus 1 is 1, because 2 minus 1, plus 3. And we know what f of 1 is. It's 9. So let's plug that in. 2 times 9 plus 3 is 21. So now we know f of 2 is 21. So now let's try letting n equals 3. F of 3 is 2 times, oh my god, I keep doing that. F of 2 plus 3. And so 2 times 21 plus 3, that's 45. Are those Fibonacci numbers? They're nearly Fibonacci, but that's not important. And so in theory, you can keep on doing this. Do we need... Can we get a general expression here? Well, let's go one more out. So in theory, we can keep doing this process until we get to n equals 15. It would save us a lot of work if we can find a pattern, though. That's what I want to see if we can find. That does make some sense. Okay, awesome. So I was hoping it'd be linear, but and I guess it wouldn't be. It might be exponential. The plus 3 would make it a little more difficult to think about. 93? Okay, that's not linear. Finish f of 4, then look at the gaps. Programming with RAM, do you do thinking skills problem? Not really. It's not usually. Okay, so that does make sense. Yeah, Cytos. And so yeah, I guess I like what chat's saying here, where let's look at the differences between each of these numbers. 21 minus 9 is 12. 45 minus 21 is I'm just gonna cheat off Jed's work. 24. 93 minus 45 is 48. Okay. And so the thing to notice, or it'd be a little bit tricky to notice this, but 12 is 3 times 4, or 3 times 2 squared. 24 is 3 times 8, which is also 3 times 2 cubed. And 48 is 3 times 16, which is 3 times 2 to the fourth. So we can find, or like, so this is our pattern right here. Like we could say that f of n, it is this, but we can find a non-recursive formula because it seems like it's always 3 times 2 to a power. When n equals 1, ooh, wait. That's funny, it doesn't work for n equals 1. But when n equals 2, we have a squared. For n equals 3, we have a cubed. And so I'd say, oh my god, you're right, Jed. Yeah. Programming with RAM. Is your stream on a delay or something? I literally did reply, dude. Fucking hell. I said I don't usually do thinking skills problem. If you want to ask one, you can. No. PhD, not you. Chaotic diamond. Yeah, that's what I'm trying to find a formula so we can save ourselves some work here. This thing here is a key realization, but it's not the actual values, as Jed is pointing out. Yeah, in programming with RAM, I'm clearly in the middle of trying to do a problem. I can't get to you instantly. Like, you're welcome to ask a question, but no, I'm not just going to drop the thing that I'm currently doing so I can, like, help you. Tertar is saying 3 times 2 to the n plus 1 minus 3. I don't know where that's coming from. Twelve times 1 times 3 times 7. I don't have any thoughts on that. I don't know what that is. I'm sorry. 123684. F of n minus f of 1. Oh. Uh, all right, program with RAM. I see your question. I'm working on this question. There's someone who asked a different question before you I need to look at, and then you would be after that. Uh, I don't know why this isn't making sense to me. Hey, Bode. Programming 3M, if you're gonna be rude to me, I'm just gonna ban you. I don't know why people are just on one today. If you want someone who's gonna give you help on your terms, then pay for a tutor. I'm giving out free math help on the internet. Yeah. I'm sorry, Kate. Kat, I mean, I'm not like getting to the conclusion as quick as I thought I would. Let me let's hop on with Jed. Please save me.
Hey,
Uh, hey.
so I'm looking at this from a standpoint of let's take a look at f of n and how it relates to f of 1. So f of 2 being 21 is f of 1 plus 12, right? 9 plus 12 is 21.
Yes.
F of 3 is 45, so it's f of 1 plus 36.
And so is the
So and then
idea
f of
behind looking at this is that
yeah.
f of one is just a constant that we can subtract off at the end, or
No, I'm looking at like so if you take f of 2, it's f of 1 plus 12. Yeah. Uh, no. 21 minus 9, not 12 minus 9.
oh, thank you. I
Yeah.
keep
So
looking
I'm look.
at the differences.
You're fine. So rather than wording it like that, if you were to write f of 2 equals f of 1 plus 12, 9 plus, or you can say equal 21, which is f of 1 plus 12, if you want to say it that way. And then f of 3 is 45, which is f of 1 plus 36. And then
Yeah,
f of
okay.
4 is f of 1 plus 84.
Wait,
And then let's extend that out to the right again. And so 12 is
oh, okay.
basically 12 times 1. 36 is 12 times 3. 84 is 12 times 7. All right.
Yeah.
So now we've got something, yes, f of 1 plus 12. Yeah, perfect. So then if we can say, okay, what's the relationship from 1, 3, 7? Well, they're all, if you take like, was it 2, subtract 1 from it and square it, and then subtract 1 again, is kind of what I'm thinking. I don't know if that's correct or not. No, it's 2 to the, I've got my last note there is different.
9 plus.
So 1, 3, 7. I'm guessing the next one is probably going to
Oh, the powers
be
of 2 minus
12 times
1.
8. Yeah, 1, 4, and 8.
Something like that.
It's 12, 2 to the n minus 1, right?
Well, 2 to
Or is
the.
it? Yeah, so f of 3 is 2 to the 2 squared minus 1, right?
Oh, yeah, so n plus
So it's going to
1.
be 2 to the n minus 1
Yeah.
minus 1. Instead of minus, yeah.
Okay, that seems okay.
And we could check that. So if we try to calculate f of 5 with this,
Oh yeah, yeah.
and then we can do it the other way and see if we get the right net value, see if it pans out.
Um,
To the
wait, no, wait.
fourth would
This
be
index of n
16.
isn't right. It's 2 to the n
N minus
minus 1 minus 1.
Yeah. 2 to the n minus 1 minus 1.
There we go. So it's 32 minus 1.
No,
Nope, 16.
16.
15.
16. Yeah.
Yeah,
So
okay.
12 times 15.
And I'm getting that into Wolfram Alpha. 180.
Yeah, 120 plus 60. Yeah. So it'd be 189 would be the number we get, right?
Right.
And if we did it the old-fashioned way, we take 93, double it, add 3, 189.
3 double it at... Yeah, okay. I buy it.
So then you could just say f of 15 is 9 plus 12 to the times 2 to the n minus 1 minus 1. And you basically got your, was it a characteristic function? Is that what they call that? I don't even know.
I guess you call it like a closed form function. But yeah, okay. I buy it. So let's get
It basically, we're using those differences, but then I was like, okay, we can't just use the difference. We have to use the differences from our starting point, which is f of 1.
yeah.
Once we detect that pattern of it's f of 1 plus 12 times something, and then figure out how that something goes up.
2 to the 14 minus 1. Plug into a calculator. Ooh, that is a big number like PhD says. 196, 605.
What, 2 to the 14 minus 1? Oh,
I'll be
Oh, that's the whole
the end result.
oh, nice. Yeah, what 2 to the 14 is what? 12,768, something like that.
Okay, so
No. 65, 535, 6 is 12, 2 to the 16th. So it'd be half that twice, 16,384. I guess. Scientific. Yeah, 16,384. Minus 1 times 12. Plus 9. Yep, 196,605.
Connect the original functions to algo. I think that's what Bode is saying, where you can probably solve it a bit more explicitly. But we just kind
Well,
of looked for a pattern here, and
The
it seems to
12
work.
does kind of pan out because 12 is comprised of 2s and 3s, which are your your 2 times the previous value plus 3. So it makes sense that the thing we're multiplying it by has a 12.
Yeah, so I guess chaotic diamond. Yeah, absolutely. Are either like the VOD will be up and you can like take some screenshots, or if you're in the Discord. Actually, wait, you are in the Discord. I'll take screenshots here and post them. And I want to run back through and explain this because it's a challenge. It's more challenging one than it seemed at first. So let me get these screenshots quick.
And the math on the right with the brackets probably it's a little confusing, I guess. So
yeah. So basically the idea of the problem is try plugging in example values of n just to get some values to play with, and then start looking for a pattern with the 9 and then these numbers over here. In intuition, what people were saying, sorry, I see what you put there too. Kind of like looking at the definition of the function, if you multiply your last value by 2 every time, a good guess is that the function is going to look like something involving 2 to the x. because 2 to the x multiplies a value by 2 each time. And so that's what led us to kind of thinking about exponentials like that. But we have to make sure that we're kind of following that initial condition, I might call it, of f of 1 equals 9. And that's why we started kind of doing f of 1 plus whatever was like left over. It's a little bit hard to explain. You kind of have to play with it and hope that you spot the pattern.
If you got rid of on the second set of the second to last set of lines, F2, F3, F4 equals, move that F2, F3, F4 equals a little bit further to the left and plug in those 21, 45, and 93 values where they are now. That might, so where it says f of 2 right now, yeah, on that section, make it f of 2 equals 21 equals f of 1 plus 12.
Oh, I see what you mean.
Yeah. And we just got those values from doing the manual calculations.
Yeah. And so we took the values we already knew and we broke it up in terms of f of 1, which is 9. We could have just written like 9 there on its own too, but we just happened to we just kind of tried this hoping that it would lead to something, and it turned out that it did. So I'll post this updated version. Yeah.
And then when you see the 137, my thought went to powers of 2, 148. And how can we coerce that 137 to follow that 148, 16, 32 powers,
Sorry, I'm messing with screenshots right now. I didn't hear that.
I was saying when I saw the 137, I'm immediately thinking of powers of 2, so 1, 4, 8, and so on. So, and these are all just like one under, with the exception of that first one, which is kind of a weird case because when you square one, you're going to get 1 back. So,
Saitos, can you drop the link to that
2, 4,
video?
8.
It probably has a better explanation than what I have here. Sorry, Jed.
No, you're fine. Actually, if you take this back to f of 1, using your f of n formula, plug in 1 for that, and you do get the same thing.
Yeah.
Because the 2 to the n minus 1 becomes 2 to the 0, which is 1. Subtract 1 from that, it's 0. So it's 9 plus 12 times 0, which is 9. So it actually checks out for f of 1 as well.
Okay. There's no problem that's waiting queue that I want to take a look at. So let's see if anything else to say about this one. Looks like it's a complex variables problem too.
I'll leave you to it. Thanks, Don.
All right. Thanks for the help, Jed.
Yeah.
Okay. Well, I guess let me try to find that black pen, red pen video because it'll probably explain it better than what I'm doing. Some recurrence about like differential equations. I want to learn more about recurrence relations because I know there are neat ways to solve them. I don't know the techniques. I don't know what to search for this. Black pen, red pen. F of n equals 2 f of n minus 1 plus 3. No, it doesn't. Okay, Colded. It's time for your problem. Sorry for making you wait. That problem, I thought that problem will be faster. Which is why I skipped to it first, but turned out to be more involved than I thought. No. Okay, I mean, it's fine. It's just I just happen to know that Coldest questions are pretty much always like lengthy. So if someone asks like a question that seems quicker, I try to get to that one first. But sometimes I misjudge like that. It's not your fault. Um, can I? Oh God, I don't know how where to begin with this one. These are depressed cubics, which make me think of the cubic formula because it's simpler for depressed cubics. I think this is a depressed cubic when there's no squared term. We know that they form a triangle, which I guess means their arguments aren't all this. No, not necessarily. We know they're not like all three collinear. I don't think there's one clean way to express that, but I assume that'll come in handy at some point. The answer is 750. Okay. It's an ice cream truck. No, yeah, Fenlocks. I was thinking just like a convenient way, like I was thinking of like eliminating this situation, but I realized that you could also have that situation that would also be eliminated by them forming a triangle. So it does feel like a triangle inequality. Like this reminds me of that. Skeleton. Thank you so much for the 3 months. 9 plus 10, 21. Hope you're doing well. But yeah, like both of these have triangle inequality vibes. I wouldn't put too much stock into this thing though, because the types of questions that Colded is doing, like they normally just make you calculate some weird value like this from the answer, because they tend to be like multiple choice tests and they don't want you plugging answers back into the original problem. So I wouldn't read too much into like that piece down there at least. But the piece up here in the bit about forming a triangle definitely make me think of triangle inequality still. I had the spoiler for the answer to the problem. For a hard problem like this, I definitely want the spoilers. Even like if anytime I'm doing like I'm trying to answer a question for someone that's like if I'm not just doing like math for fun, I welcome all the math spoilers because I don't want to say something that's incorrect. On the slash work is in the journey. It's not if I'm like trying to tutor someone and I'm telling them all the wrong things. So I that's why I want all the spoilers here at least. Um so I have like done that before. Q and R unknowns. Why not just rewrite everything in factored form? Uh well, how would they factor if these are cubics though, Territar? The cool Minesweeper theorem? No, I don't think so. Oh, I see what you mean, peach tea. Yeah, yeah, that's fair. Oh, doing okay, so not naming some new constants. Also, the use of Q and R reminds me of like division algorithm. Do a Minesweeper. Let me think about this one for a bit. No, all right. Thank you. Oops. Hey, boss dad. So we could think about this. They don't factor the same way though. A, B, and C, I guess, are real numbers. No, 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 they're not. They're imaginary. Shit. So yeah, I guess I don't see what's so helpful about this. Because I I imagine these concepts need to be different. And even if they were the same, I don't know what to do with that. Oh, Storm, did you change your name? On Red Shirt was the first time chat. I would believe it. Does that mean Storm of Bread? Your name? I never thought about that. It's more like x cubed minus. You lost your previous account? Oh, okay. That's funny. I wouldn't mind being caught in a storm of bread. That sounds nice. Take any Minesweeper board, sum all the numbers on it. Now switch every bomb for a non-bomb and vice versa. The new number is such that if you sum them, the sum will be the same. Really? That's weird. So does this equation follow from all three of these being equal to 0? Like, is it saying that all three of those equations have to share a root if it's the same number x? X is not a number. You consider a polynomial. Oh. This system can be translated like this. Well, I'm a little bit lost on how that works, but like, how would the rest of the argument go if I just accept that? Oh, Vieta's formulas? Huh. Oh, okay. So this might not be the solution you're saying. We'll at least write it out. But so here the roots are the z's. Um, b is 0. So z1 plus z2 plus z3 is 0. Z1, Z2 plus Z2, Z3 plus Z1, Z3 is C over A, so which is just minus Q. Z1, Z2, Z3 is minus R. If you assume a root, then you can find the relation of the other roots by factoring slash long division. Like, does a complex cubic have to have... I know a regular cubic has to have one real root, and the other two could be imaginary or real. It's the same thing true for a cubic like this, though. Some manipulation, you should find what you want. Yes, it would be. Okay. I was Taylor on the YouTube chat put any of these things related to that, but I'm not sure how to use it. No, I don't know. Coefficients are real. Okay. I don't know. Oh, right, because we're plugging in imaginary inputs, but the coefficients are still real. That's the important part. Right. Okay. Anyway, can we manipulate Vieta's equations here to like get this form? And I assume along the way somewhere we'll need to use this fact. How can we probably need to square something, right? Maybe not. Second one 3 times and add them. Uh, okay, that helps, Storm. So you want to take the second equation and factor it 3 different ways. Square the first one? Okay. um, I'm just gonna make Wolfram Alpha do this for me. Windows is the worst sometimes. It keeps resizing my windows for me, and I don't want it to do that. Okay. Um, Factor it by 2, like as in grouping all of these together. Oh, nice. Because it matches this. Um, I really want to plug in 250 for the other part, but I know that can't be right because like the magnitudes isn't the same thing. Can we say something about the magnitudes though? I don't know. Does if z is equal to a plus ib, z squared is a squared. Oh, it's minus b squared. Never mind. If it was plus b squared, I thought we could like find a hidden magnitude, but no, we can't. We haven't used the third equation yet. Start with k and try to modify it so we're going from the other direction. I don't know how can we break that up though? Like, do we have to break up z1, z2, z3 into like a real and imaginary component? You stay with z1, z2, z3 without changing them? Okay. How do we create? I mean, at some point we need to look at the magnitudes of these, I guess. If we want to use that fact. The third module is easy to compute. I don't know the rules for modulo. Or what happens? I really need to study complex variables at some point. I shouldn't be this bad with them. That's it? Okay. If you take the modulus of each side and square it. Right. I'm just thinking, oh wait, you can even split it up with addition and subtraction? I didn't. Okay. Uh Wait, so don't we know what Q is? Like, why don't we take the modulo of this thing? Or modulus. Blech. I hope this is valid. It's wrong? Modulo isn't linear. Oh, it'd have to be. Oh, that's conjugation. Oh, frick. That's that. I don't know why. Oh my god, dude. My brain is cooked. This is not a good day for me. I was literally getting the symbols mixed up. Vertical bar versus horizontal bar. uh, Bluebird. Modulus of z squared is equal to z times z conjugate, right? Hmm. Okay. I think like this. Because the conjugate is linear, so we can do that. Ugh. Nope. Oh my god, dude. I just made a vector arrow. This is bad. I think this is what has to be done, even if it is painful. I feel like I don't know. Is complex multiplication commutative? I'm pretty sure peach tea, yeah. Like, yeah. Like you can interchange like these two things, yeah, yeah. Because you can always prove it by breaking it up into the real and imaginary components. Um, so we don't need to work out each one by hand, but we could, just look at the pattern and figure out what it should look like. Piritar. Maybe paste it over to the Twitch chat too, just in case someone finds interest in it. Oh, I wonder if there's something there. I'm not sure. Okay, so the first bit I'll do in green. Actually, let me just copy paste. Never mind. I'm not gonna do it in green because I want to copy paste what I just wrote. That part I'll do in green. I should do this on another line. This is gonna take a lot of writing. Factorize by 2 and you'll erase all the modules. Yeah, right. That was my hope with doing this. Okay. And so I'm just gonna cut out some of the middleman and go straight to saying 500 because we have basically 2 times this equation. And then what's left over? You're saying the other 3 formula, it should end. Yeah, I feel like we should be able to do something with this, but what? Like, it does nearly look like that, doesn't it? Luber, do you want to investigate z1 times z2 bar? It's the conjugate of like that. I guess we need to go into components if we want to prove something like this. Storm, you're just saying that this is true? Okay. I'm just going to take your word for it then. Um, then when you sum them, you get 2 times the real component of z1 times z2. So you're saying that given this identity here, when you have z1 z2 conjugate plus z1 conjugate z2, oh, I see why. Yeah. Because you would apply the identity to just one of these. Conjugate, and that gives you just the real part. Sneaky. 2 times the real part. Wow. Um, and so the formula we're going to use up here is it's equal to minus q. So it seems like the minus 2q is a good call. Or, well, maybe we'll get a couple extra q's. Let's see. Because we can take the real component of each side of the equation here is the point, and q is a real number. And I think the real component function is like linear, so we can split it up like this. And q is already real. Okay. Um, wait, where did this 2 on the outside come from? There is no 2 on the outside, right? No, the 2 on the outside comes from that. Yeah, okay. So 500 plus 2q then, because we are getting minus and negative. So we just need to figure out what number q is, I guess. Well, so the spoiler is that the answer is just 750. Um, apparently you can figure out what q is. when we squared the first one. Okay. It's like right around here. Cytos, there's no way in hell I know the answer to that. The last line. Okay. That's one that I wanted to take the modulus of, and then I realized that I was doing it terribly wrong. Can we use that in a different way, though? Instead of squaring like a murderer, maybe square the module and use the same trick. uh, um, are like take the modulus of this equation here and then square it? Okay. Well, if I'm going left to right, I guess I'll do it for one more step. And then this is where we conjugate, maybe. Um, yeah. I guess we can do bar, bar, bar even. Um, and so we could multiply this out. What would the end goal be? We want to find a relationship between Q and the modulo, the moduli, moduli. So I assume we need to multiply this out, unfortunately. Because on the bright side, that's z1 modulo squared, modulus squared. I keep saying modulo. Conjugate the second equation because Q is real. True. Yeah. Didn't I like? Did I already like do this once? Is there anything I copy paste? Oh, it wasn't quite the same, right? Yeah. Ugh. Just doing this the hard way. Okay. And we don't even get common terms, do we? We can get some real component stuff though. Uh, we can probably use the same trick that Lubert pointed out to actually make progress here. Because we can match that term with that term. Yeah. So that's from those two terms. Um, from that and that. It'll work? Okay, good. It's music to my ears. Um, so then we get 250 uh plus minus 2q equals 0. Yeah. Q equals 150. So then 500 plus 2q is equal to 500 plus 250 equals 750. Storm, what a Chad. Oh my god. You know, Proctor J says pencils down, true. Lubert also. Wow. This problem was a journey. Yeah, Taratar. It really was. Thank you for trying with your method too. The square, the true, yeah. And this is your flex more than my flex. Uh, Storm's flex. There we go. I'll flex on your behalf. Okay, cool. Then. I don't know if you're how much of this you were following. I think I can explain all this except for like the very first part here. Yeah, the screenshots, absolutely. It doesn't depend on R. Yeah, true. I couldn't tell you why. Oh my gosh. You know you're asking an involved problem when I have to do this across at least 3 screenshots. No, we're going for 4 screenshots. Okay. The roots only depend on each other and not that of Q, not R, interesting enough. Yeah, right. Someone's yeah, I'm just seeing that now. Would you mention an alternative such geometric answer? Yeah, sure. You can post it to elements? Yeah, that's fine. And I can transfer it over for Cole to see too, to my server. Vietas are powerful. Yeah, I usually they're only needed for really hard like problems like this one. I've seen them before, but yeah, I definitely don't have them memorized. Oh, uh, it shouldn't. Does it matter if it's all real anyway? Well, I guess that would affect the multiplication though. I don't know. Storm is the is the one who's carrying me. Um, yeah, even Luber is saying that the math is still fine. Just how I wrote it might be a little bit weird or inaccurate. Let me do the Minesweeper that Peach Tea redeemed 48 minutes ago now. While we wait to see Collar's solution. No guessing. Oh, I misclicked. That could have been a bomb right there. I didn't mean to click on that one. I got lucky. $37 seconds? Not the worst. What is efficiency? I could have done it in less clicks. I never even thought to optimize that. I wonder how you know, like where. I thought you just don't know when there's an empty zone though. Hey, Mangif, thank you. We can get rid of that. Um, so it's like okay, Storm is agreeing. There should be a bar in that. A bar in all these. Oh, a bar like that, I guess. Is that the thing? And I can do it elsewhere in the work too. Do set Z1 is real and Z2 equals Z3 bar. That makes sense. Because it comes from a cubic. Should be bar. It's Buster Scruggs. Thank you for the follow. Scotch on the rocks. Yeah. Ugh, I'm getting a drink after this stream. I'll tell you what. Um, wait, am I stupid? Which one has the bar? Which one doesn't? You know what? I'm just leaving it. My brain is fading. Or oh, does it not matter? Okay, okay, okay. Then I'll just put over whichever one I like more, or maybe less. Thank you for the correction, Lubert. Um, maybe I should update my screenshots. That's you, Cook, isn't it? That's your YouTube name? um, how did? Yes, I remember. See, I'm scarred from you like trolling me, and I didn't realize it was you. Let me update the screenshots that I posted. Wait, what? Hello, hello, Cook. Uh, why did my journal plus plus go away? What? Did it crash? No, okay, it's just I minimized it. Should all do a shot after every JE solve? Yeah, no, it doesn't need a driver. True. That's the biggest plus of uh wait, what? What? What did I just do? One second. Oh no, I don't know how technology works. It's okay. I was just checking the screenshots that I posted and they looked weird, but I was just looking in the wrong place. All right, Storm. Thank you so much for carrying me through that problem. Sleep well. You've earned it. Um, yeah, I hopefully just fix everything now, so or hopefully we're okay. Okay, I started streaming. I was looking at my answers here, and I think I was just graphing them in decimals wrong. Oh no, oh no, I got them slightly wrong. There's really negative ones at the end that I was missing somewhere. Yeah, this is from Zach's analysis class. It's one of like the bonus problems we didn't have time for. I was working on it both at the start of the stream today and I think on the stream on Thursday. I got the series slightly wrong. I think I forget which one Zach actually like checked, but there's supposed to be a -1 to the k. I think on that one, or maybe both of them. And I'm trying to figure out why. Yeah, I mean, really, for me, it should be frowny face equals arcsine. They're saying smile equals arcsine prime. I think you're making a joke, and then I realized that you're being serious. Oops. uh, no, it's the integral of Smiley as arcsine. Being like an intro class hell. You wrote arcsine prime. Oh, I'm sorry. Uh, you're right. Yeah. Sorry, I got it mixed up. I should just know better than to doubt you, Storm. My bad. Do you have to teach super big classes, Cook, or like would you just rather teach higher level material, or both, or like kind of curious to hear about it. The size and motivation. Oh, the motivation of the students will be a big one. I can see that. Pre-med physics 2. 100 students. You only have one TA. Oh my god. That sounds like a lot. You should just go work in Bedbox's tutoring center. It seems like a nice gig. Where you're teaching this way and not this way, while they can't solve any problems. Hmm. That sounds really annoying to be like questioned by the students like that. Like I've had students in my classes question the professors too, and it's like I wonder why they feel that like like why would that be okay? Chat GPTA, true. I mean that's probably why so many professors use the online homework websites. Send me a pretty aggressive email saying I switched to PowerPoint instead of writing things out. No, what? I'll probably because they just want to copy the power, or they want to have the file PowerPoint slides. So they don't have to copy things down for themselves. That's just lazy. Like professors who use PowerPoint slides is like, yeah, it doesn't have to be a bad thing, but it's usually just a way for them to be lazy. Like I don't know why you would want that. Yeah, yeah. 3 is the way that I feel as a student. Like I give the professor the benefit of the doubt that they're probably doing things pretty okay. Like I wouldn't tell them to like change their mode of the teaching. It would be on me to like, ideally just transfer to a different class. Large room they can't see. Project an iPad. Okay, so hopefully that would solve PhD's. That would be valid though, PhD, yeah. But they could phrase it a lot better if that was their concern. Or like, yeah. Hmm. Yeah, that sounds a little weird. There's one classmate of mine who would like actually take videos of all the lectures, and I can understand that as long as like you get permission from the professor and stuff. Or I guess it was probably an accommodation or something, but um, like just the pictures, when they're already posted seem a little weird. Yeah. Where does this negative one come from? This is kind of this is weird. Gonna do teaching. I would have thought college would be better. I bet it depends what college you're at and what you're teaching at that college. I have a similar perception though, Peach Tea, that college would be a lot better. I don't know. That's my guess. Hell if I know. Coming midterm, also was super comprehensive. Questions on the midterm at the start of lecture yesterday. No equation sheet, but a filled out index card. It's wrong. You don't give us an equation sheet. Oh God. That is surprising. So goddamn many frickin' limit variations. Uh, yeah, Lucas, it's really because uh what am I trying to say? Limits are defined a little bit differently when they're going out to infinity or at like an asymptote or something where the function isn't defined. It for all that though, you can develop like an intuition where you just kind of can figure out how the function behaves and have a good guess for what the limit should be. But yeah, especially when you're first starting out, there's a lot to know. I agree. Oh, Storm, is that where my issue is with the binomial coefficient? How would you put away 2x root? 2x in root of. Okay, I'll think more about that in a minute. Let me. Well, wait, Lucas, are you saying the entire thing is under a square root? 4x squared minus 5x plus, or maybe just that piece plus 2x like that? And are you doing the limit to infinity? Okay. Let's go and work on this problem then. Someone just got scammed. No, the problem that you were looking at was just like a study question. And even then, I wasn't even like working on it, to be honest. I was just running my mouth. Um, Cook is calling that a 0. Let's find out. So whenever I see a limit with root of something weird plus something normal, the trick that I always do is I multiply it by, it's called the binomial conjugate. The actual name of it isn't too important, but you take that plus sign and you flip it. And if you have a minus sign, you flip that. Like that. But this is a plus though, Cook, isn't it? That actually isn't what your book does. So we're saying factor it? It was originally minus, but Lucas changed it. 2x, whatever this is. Yeah, actually, we should be able to just look at this one, right? Okay, maybe how your book is doing it. Okay, oh, that's what Storm is saying with the 4x. I get it now. Okay. Uh, okay, there's a different way that's probably quicker than what I'm saying. I'm going to start by working underneath the square root. Just go with this for now, and it'll make more sense why later. I'm going to factor the 4x squared out from the inside. So 4x squared, 1 minus 5x divided by 4x squared, plus 1 divided by 4x squared, plus 2x. And now when you have a square root in something times something, they can get their own square roots. And the square root of 4x squared is just 2x. We're not going to worry about absolute. Well, I'm not going to do the absolute value because we should be able to know that. I'm just not going to do it. I don't want to over explain this, and we shouldn't have to for this problem in particular. Plus 2x. And now we get back to the 2x out of here. And we get 1 minus 5 over 4x plus 1 over 4x squared plus 1. And so now when x gets large, the 2x goes to infinity. This piece here, these two terms go to 0. So it's like 1 minus 0 plus 0 rooted plus 1. So that's just 1 plus 1 is 2. So it's basically 2, like, it's infinity times 2, and that's still just infinity. So that's probably how your book was doing it. And yeah, Cook, I agree. That's like a lot quicker of a way to do it. The shortcut that Cook is saying is that so I mean this is probably the solution that like your book wants. I don't know how picky your teacher is, but there's a quicker, more intuitive way of doing this limit that Cook is pointing out. uh, which is that for large values of x, when you have a polynomial, you only really care about the highest exponent. Yeah, as PhD is saying, like this x squared or the 4x squared is way more important than the 5x plus 1. So you could think of it as basically the same thing as root 4x squared plus 2x. And that gets you to the answer a lot quicker, but depending on your teacher, they may or may not like that, is my only warning. With limit out front, you don't even need the approximate sign? Really? And I can talk about the x over x thing. Limit as x goes to infinity of x divided by x. So yeah, Lucas, you're right. If you have infinity over infinity, you can't do like, you can't cancel an infinity with another infinity and say that's one and that's one. That's not good math. Like you are right about that. How you do think about this limit though is we're never in danger of dividing by 0 here. We're plugging in huge values of x. So let's just cancel the x's because we're never dividing by 0 anyway. So x divided by x we know is just 1. And the limit of just 1 is still 1. Now, I think something that might be helpful to see, or maybe confusing, is x squared over x. This is another infinity over infinity situation. But we get a different result. Because we can still do our same cancellation and get just x, but this one goes out to infinity. And so that's why it's not good math to say infinity divided by infinity is 1, because it's just not always true. In each case, we had infinity over infinity, but they were like different types of infinity. Hey, Chandu, welcome in. There is a math category. To be honest, I think there's a game called Math or something like that, but me and others have like, just started using it for actual math. If you're interested in math streams in general, I'm not the only one. Whenever I see a new chatter, I like to let them know. Thank you for the follow. There's a whole list of math streamers there to get you started if you're interested in math streams in general. There's even more than that too. We need math people? Hell yeah. Welcome in. You'll never be a chat. Ugh. Gotta stream more, cook. Fix your internet, or I don't know what the internet's like at your new place, but Lucas, you're asking what is the biggest known value of infinity people know of? Oh yeah, that's fair too, Cook. That that's a very there is no maximum that you can name. There's or like you'd always name a higher one, I think. Is maybe the it depends also the context of math that you're talking about, but I think maybe the kind that's relevant here are infinite ordinals, I think is the name. How do I pay rent? Uh, I have a lot of savings and I'm allergic to spending money. I just live a pretty frugal life for the most part. I have some things that I will spend some money on, but yeah. The Bay Area is expensive. Uh, if you like the jobs, at least the job I had a correspondingly high pay though. It's savings that I worked for. I'm not rich. Um, no, I wasn't in tech. I couldn't get accepted there. I was an HR dude. Um, I don't know enough about this to really say. Yeah, and so Storm is giving a more formal way of saying what I was like trying to say. But basically, what he's saying is if you claim you found the highest infinity, someone else can always name a higher level of infinity. So there is no like one maximum that you can name. There's always a higher one. Basically, yeah, just always plus one. Well, yeah, like I was working that job for years and not living life or having any fun ever. That's the truth. I live a pretty boring ass life, dude. There is a reason limits exist. Yes. Can always say plus one for every number. Yes. But you need a threshold. Um, I'm not quite sure what you're trying to say. Okay, so that one I can maybe address a bit better. And Desmos is the place we want to go. Um, so let me put a few functions out there. Okay. Here I have three functions. They all go out to infinity the farther out to the right we go. But they clearly go to infinity at different rates. It's just that they take more time than the others. So it's like they're all ending up in the same place, but they just get there slower or faster than each other. And as it turns out, there's a whole kind of hierarchy of functions where a linear function beats a logarithm, a quadratic beats a linear function, a cubic would beat a quadratic, and what's even better than any polynomial is an exponential. So 2 to the x would even beat the cubed after a certain point. If you go far enough, you'd see the 2 to the x would eventually take over the cubic. I can maybe do 10 to the x, and that goes a lot faster. But you can even beat this with the function x to the x. Again, you have to go up a little bit. And you can beat that function with x to the x to the x. And you can keep on stacking more x's on top of each other. And that's why there is no kind of like greatest infinity, because you can always name something that's like bigger. F of x equals infinity times x? What is that? That's just a vertical line? X factorial 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 beats everything? Oh, it's doing the gamma function for negatives. Yeah, we can bring factorials into the picture too. Hey, Papadoria, on Thursday, I did think more about your integral, but I think I'm kind of stuck on it. It doesn't seem like it's possible that I can figure out. Andy math? I don't think I've heard of them, no. Ackermann function. I learned about that in discrete math. What's that about? Oh, is it faster? Oh, it's faster than the multiple factorials? Yeah, I remember I learned about this at one point. On the growth of my savings over time. Oh yeah. I haven't seen all these ones. Oh yeah, see a storm. You said goodnight a long time ago, didn't you? Go to sleep. The 10th Dedekind number? Oh, I've looked this up before. I forget how they work. Show me the function. This is a short, but it's too long. Your brain is too innocent to understand such a solution? Your brain said that? Oh my god. Those are some nice curves. You repeated it. Hey, Suna, yeah. I'm doing good. How about you? Yeah, exactly, Lucas. I guess your professor just likes giving you impossible questions, Papadoria. I don't know what to tell you. No, Cook. I hope I don't hear back. To be honest, I feel like if I hear back right now, it's gonna be no's. So one problem we should be able to solve, which you do have. Oh, okay. There's no line, no. Um, I'm waiting on 4 applications, so I messaged this to Cook, but for anyone who's curious, I've applied to 6 grad schools. I heard back a no from the school that was the biggest reach that I applied to. Um, and then from another one, uh, I heard no for a PhD, but they accept me for an unfunded master's, which is not the most appealing thing, but is there. But yeah, I don't like that I heard back so quickly on those because it just makes me think that I didn't have a strong application at all. I'm waiting on 4, yeah. X equals pi. What's the exact value of x? No rounding. It's pi, Lucas. um. So let's say the natural number is, I guess, D1, D2, D3, D4. 3 for small bags of pi. Those questions are annoying, Lucas, but I feel like being able to do that is like actually a good skill. They need to be phrased well. Like there's always some poorly phrased ones that are just bad questions, but I feel like for math in real life, that's just kind of how it goes. Like I guess for like applied math, that's how it goes. And so I guess if we just say that D1 isn't equal to D2, just arbitrarily choose those two as the different ones. Apparently, actually, that's not good. That's not that loses generality. Oh, I think I wouldn't take medical advice from YouTube, Lucas. I think looking at a screen messes with your eyes. Um, that makes more sense because I was wondering if you could just have two numbers that are less than 6,000. Yeah, peach tea. So, oh wait, no, they have to. Oh, it's to be distinct though. Proof by cases. There's only 9,999 to check. True, Territar. Oh wait, it should be descending minus ascending, right? I wrote that backwards. Yeah, this is weird that this works, evidently. Uh, well, no, not necessarily. Well, I mean, no, hmm. We can just assume that we're given a number in descending order. Because you can always scramble them however you want and get the same order back. Hopefully, Jed. Is there an issue? Oh, yeah, okay, that's good counterexample, PhD. Yeah. Oh, you do it repeatedly. Okay, that's an important bit. Proof by cases might yeah, it's hard. Maybe. With within 7 iterations. I might rather just look at the proof that's hopefully posted on this Wikipedia page than try to figure it out for myself. Uh, that is kind of an amazing fact, as you say, Papadoria. Yeah, that it only takes 7 at most. Narcissistic number. It's all about 6174. How did he think he would prove this? Approves my innocent brain? I don't know. It doesn't seem like a Wikipedia page. It just states the result. It doesn't show it, apparently. Uh. Oh, wait. Yes, you do the sorting. So after the first iteration, you have 80, 82. You do descending minus ascending. Then you get 85, 32. Then descending minus ascending. To the tune of the Flight of the Valkyries. Hey, Mega. I'm hoping this paper that Wikipedia referenced has what we want. Yeah, I can try and it's the exact thing that Dr. Cook linked, is my understanding. Yeah. It's this like it is just this. When was this published, by the way? 2017? Yeah, I mean, it like this is the reverse of this, to be fair. You know, this also works in other bases, apparently. I assume it'll be 6174 in whatever base. Well, maybe not. It's not always. No, that probably just depends on what base you're working in. What your fixed number is. Probably not the same. Okay, wait, this seems important. So they're doing it for an arbitrary base. We can, anywhere there's a B here, we can say there's 10. Racker packs problem instead of Kaprekars. I guess let's try doing this procedure here. Death Road to Canada? No, I've never heard of that. Apparently, yeah, it works in other bases. I doubt it's the same number. Well, I guess we know it's not the same number because it depends on B. But apparently, yeah. So I think this is where Territar was, or I think Territar suggested this at one point of breaking things out into their places multiplied by 10. And so now we want to examine 10 cubed x0 plus 10 squared x1 plus 10. What am I doing? Wait. No, oh my god, bro. If it works for non-natural bases? Oh my god. Did they make a claim for... I wonder if this paper makes a claim about what the bases can be. I don't know. What is b factorial, 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 factorial? Yeah. That's weird. Um, aren't one of these numbers negative? Same with these two. Well, by the construction of the problem, these two are negative or zero, right? Right, we have to keep on iterating that too, Territar. I forgot about that. And I'm a little concerned by having apparent negative numbers. Did I do it wrong? Shouldn't the order be flipped or something? X0 is the biggest number. X3 is the smallest. Yeah, it's not as simple as I thought. I forgot about the multiple iterations piece. Wait, so 9 goes into 6174? 54, you get 7. Wait. Wow, it does. Uh, I don't know what this bar means over this piece, but hmm, what am I trying to say? It's a little bit hard to reconcile. They're doing things as generally as possible for any base and any starting number, or for any number of digits and starting number. Uh, and I'm trying to figure out a how their work works and how we can simplify it down to just our case. So I don't think we have to be as fancy as they're being. Um, I feel like I wrote this like second line wrong or something though. I'm kind of concerned about it. Oh wait, oh maybe it's okay. I need to. No, I think it's actually okay that it's like this. It's okay that we have negative numbers, I want to say. Like, Do we want to factor it by the x's? The x3 is kind of weird. Wait. There. No, that's still bad. That's how it should be. I think. Maybe. I don't know if it's helpful or not. I'm just messing with it. Can we somehow factor this? Because it seemed like that's what they did. Like, they factored, like, 10 minus something out. Do they all have a factor of 10 minus 1? Can we say that? What's the difference of two cubes? Yeah. Again, I have no clue if this is helpful, but I think we can validly factor out a 10 minus 1. I assume we can simplify these terms that I'm writing right now, but just for now, I'm not going to. Um, that's 10 times 10 minus 1. This is probably needlessly complicated, but just to see it. Does this help? Not that I can tell. True. Yeah, yeah. What I think we've shown that this number divisible by 9. So we could say, but x, we don't know what the digits of this new number are, though. That's the issue. Well, yes, we can. We can figure it out. And that's why I should have kept it in this form here, maybe. Let's group it by 10 squared, like powers of 10. Did I already have this? I basically already had this, but I'm going to regroup them. Who cares? So if it's divisible by 9, we should know that these are the digits. Well, it's 9 times that. No, this still isn't helpful. The paper did mention the sum for a geometric series. It's not the. I don't know. I was thinking we're somewhere around this stage, but I don't know. Is it always possible to find a divisibility trick? Well, I don't know about always. I assume no, but I don't really know. That's an interesting question too. Or maybe the answer is yes, but they just get too complicated to be helpful. Okay, you distracted me. Can you? One to 13. I don't see them. No one's answering the actual question though. I don't know. I bet the answer is yes, but they just become too complicated to be considered tricks. I don't know. That's like a number theory thing, and I don't really know number theory. Yeah, that's what I was thinking too. Like you have to show it's possible for every prime, and then I think the rest would follow. Oh, the bar means like concatenation. It's not multiplication. It's this is the first digit, that's the second digit, that's the third digit. I get it. Okay, I see Mateo in YouTube chat just posted a problem. Let me take a look at it because I'm kind of stuck on this. I'm gonna be honest. I'm sorry, Papadoria. I feel like I maybe have something here, but I don't quite know what to do with it. Sorry, when I say here, I mean like here. Um, it wasn't for any points anyway. Oh, okay. Mateo, I wonder if I'm making this too simple. But if 10 to the x equals m, and m is an integer, then x is equal to log base 10 of m. Um, and log base 10 of m is an integer for m equals 10 to the k for k any integer k, I guess, right? So I think that's just the answer right there. I'm not quite sure what more to say about this, Mateo. And we know if this makes sense to you, but um oh wait. M could be negative, right? Oh no, positive integer. So if M is a positive integer, then I guess it should be positive integers union 0 to be more accurate. Well, I'm being too fancy. I think this is fine. See, yeah, Mateo, it's just I meant irrational number can be the solution of the equation. Well, I mean, I think that still. I mean, I could have written x here because x equals log base 10 of m. But yeah, x is irrational. Um, like unless m happens to be like 10, 100, 1,000, x is going to be an irrational number. That's kind of like in plain English what's happening. And that's how logs are kind of, that's how logs work. Wait, m is a positive integer. Um, I can put into Google Translate. I think you translated it accurately, I think. So I don't see the issue. I'm trying to think what else this could be. Be more formal about it. Yeah, I yeah, maybe that's it. Maybe that's what Territar is saying. So maybe Mateo's supposed to prove by contradiction. Um, we could assume x is a rational number and show a contradiction. Territar is raising both sides of this equation to the power of b. Do we get a contradiction here? I don't see the contradiction. Then you can show that m equals 10 to the k for some integer k. The original statement was true. Yeah, right. I'm reading your thing back a couple times. Why must that be true? Oh, well, prime factorization. I guess so. Yeah. Okay, yeah, that's a good point. What do you say after that? Um, However, 10 to the a is 10 to the k to the b. So a equals kb. Fair. I guess this is what you the only thing we can think of then, Mateo. And thank you, Tartar. I think I follow this. Yeah. No, I don't. Fair enough, Sora. Oh, that's a good. That's just a Twitch global emote. That's a good one. Just kind of rare for Twitch global emotes, to be honest. All right, I think I want to wrap the stream up soon, Mateo. So if you have a question, just like let me know relatively like let me know quick, or else I'm probably gonna call it here. Oh my. Okay. Not seeing anything from you, Mateo. I hope this helps. Thank you for trying. Uh, I'm getting tired though, so I think I want to wrap things up for the day. Um, so yeah, I guess I'll do that. Territar Papadori slash Pigmaster Mateo. Anyone who's here on YouTube, thanks for being here. Um, I'll see y'all later.